Hi, this is Mrs. Nandor, and we're going to talk about dimensional analysis. So dimensional analysis is a general process that we can use over the course of our entire year of chemistry and beyond to use units to guide our problem solving. So it's it is a way to convert units. So if we know a measurement in one unit and we need to get to that measurement in a different unit, dimensional analysis is the process we're going to use to convert between those units. Dimensional analysis can be one step, it can be many steps, and we're going to walk through several examples. But first, let's kind of go through the general thought process or steps for dimensional analysis. The very first thing that you're going to want to do is you're going to write your given unit and your needed unit. So what are you starting with in the problem? What are you ending with? What unit should your answer be in? So those are going to come straight from the question. It'll tell you what you're starting with, and it will tell you what you should end with. Then you're going to write in a unit plan. And your unit plan, you're just looking at how to get between the units. You're not worrying about numbers right now. So you're using some of the equalities that we already know. So we know that there are a certain number of grams in a kilogram. So we can convert between grams and kilograms. So we're going to place our units so that they'll work out, and our starting units will go away and we'll end with the units that we need. Then we're going to fill in the equalities, so then you're going to actually put the numbers in. So for grams and kilograms, for example, we know that there are 1,000 grams in a kilogram, so we put the numbers in. Step 4 is to do the math, and then our last step is to write the final answer and making sure that we include units. So I know this is confusing. Let's walk through a couple examples. So our first example says convert 13.5 meters to centimeters. So we're going to start with step 1. So step 1 says to write our given and our needed. So we're given 13.5 meters. We want to end with a number in centimeters. Okay, so now we're going to set up our unit plan. So our unit plan starts looking like that. So we are going to put units in here so that meters will go away and centimeters will stay. So we're going to rely on some of our math knowledge. When it comes to units and fractions, we know that if we have the same units on the top and the bottom of a fraction, so the top and the bottom of this line, they'll cancel. So we want meters to go away, which means we're going to put meters on the bottom of our unit plan. We want to end with centimeters, so we're going to put centimeters on the top. So our meters units will cancel. We'll be left with centimeters. Our meters units cancel because they were on the top and the bottom. So if we extend this dotted line out, whatever's on the top and the bottom will cancel. So now I have to write in my equivalencies. So I know that centi means there are 100. So there are 100 centimeters in 1 meter. So I'm going to put in 100 centimeters in 1 meter. And now step 4, I need to do the math. So I'm going to multiply everything across the top, everything across the bottom, and then divide. So we could do this in our head, but I'm going to make sure it's right in my calculator. So in my calculator, I'm going to type 13.5 times 100, and then I'm going to divide that by 1, which is the same thing. And so we get 1,350 centimeters as our final answer. So 13.5 meters is the same thing as 1,350 centimeters because there are 100 centimeters in 1 meter. Let's do another example. So our example 2 says convert 2.5 kilograms to grams. So I'm going to start with what I'm given. I'm given 2.5 kilograms. I'm going to end with grams, so I'm going to write that over there. I'm going to set up my conversion factor. So this here in the middle, once you have your numbers and your units in, is called a conversion factor. So I'm going to set up my conversion factor. I know I want kilograms to go away, so I'm going to put kilograms on the bottom. I want grams to stay, so I'm going to put grams on the top. I know that kilo is bigger than grams, and it's 1,000 times bigger. So for 1 kilogram, I'm going to have 1,000 grams. Now I need to do the math. 2.5 times 1,000 divided by 1 gets me 2,500 grams as my final answer. Let's do example 3. Example 3 says convert 0.53 kilograms to milligrams. So this one, we don't know how to get straight from kilograms to milligrams. So we're going to break this into 2 steps. So we're going to start with 0.53 kilograms. We want to end with milligrams. Now, I don't know how to get from kilograms to milligrams, but grams are in the middle. I do know how to get from kilograms to grams. So I'm going to go ahead and put kilograms on the bottom. I'm going to put grams on the top. That'll get rid of my kilograms units. I'm going to do a second step to get from grams to milligrams. So now I need my grams units to disappear. So I'm going to put grams on the bottom. I'm going to put milligrams on the top because that's what I want to end with. So my units all work out. Notice I haven't put any numbers in yet. We're just following the units. So I wanted kilograms to go away, so I put it on the bottom. I know how many grams are in a kilogram, so I put grams on the top. Then I did with the same thing going from grams to milligrams. Put grams on the bottom so it would go away. Milligrams is what I'm left on top with because that's what I want for my final answer. So now I'm going to put the numbers in. So I know that there are 1,000 grams in 1 kilogram. And I know that there are 1,000 milligrams in a gram. So I'm going to do 0.53 times 1,000 times 1,000 divided by 1 times 1, which is 1. So 0.53 times 1,000 times 1,000 gets me 530,000 milligrams. So if I have 0.53 kilograms, it's the same thing as 530,000 milligrams. Let's do one more that doesn't use metric units. Let's do a conversion that involves something we know in everyday life. Let's do days and minutes. So I'm going to start with what I'm given, just like I always do. So I'm going to start with 31 days. And I want to get to minutes. So I'm going to end with minutes. Now, I don't know how many minutes are in a day off the top of my head. I do, however, know how many hours are in a day. So I'm going to go from days, I'm going to put that on the bottom so it'll cancel, to hours. And now I know how many minutes are in an hour. So I'm going to put hours on the bottom so they'll cancel. Minutes on the top, because that's what I want to be left with. So I didn't know how many minutes were in a day. However, I know how many minutes are in an hour, and I know how many hours are in a day. So I can use that as my intermediate step. So I know that in one day there are 24 hours. And I know that in 1 hour there are 60 minutes. So I'm going to do 31 times 24 times 60 divided by 1 times 1. So if I do 31 times 24 times 60 divided by 1, I get 44,640 minutes. So if I have 31 days, I have the same thing as 44,640 minutes. Dimensional analysis can be a confusing process at first, but it is extremely helpful as we move through this year in chemistry. So it's really important that you do lots of practice and ask lots of questions now.